Hello all and welcome to Pankaj Sir's Echelon Tutorials. In this today's session, I am going to talk about the forces between two electric charges. Okay, it's a small topic, a small introduction. I want you to understand the meaning, the definition of the force between two electric charges. Okay, so let us get started. Suppose you have two charges. Okay, one charge. Let these two charges be Q1 and Q2. Let the distance between the two charges be okay, R. Okay, that is the distance, right? This is point A and B. Okay, now the charges are of two types, either positive or negative. So assume that both these charges are positive, right? Now, by Coulomb's inverse law, we know that the force, because these are two like charges, both are positive, so there will be a repulsive force. So this force of repulsion will be directly proportional to the product of the coulomb of the two charges. Okay, coulomb value of the two charges, right? And F, that is the force of repulsion, will be inversely proportional to the distance square between them. The distance between them is R. So F will be inversely proportional to the square of R, is R square. If you combine these two, you get F directly proportional to Q1 to divided by R square. Now, this F, this proportionality sign, if we remove and put equal to sign, then we'll have to put some proportionality constant, say K. So F will be equal to K times Q1, Q2 over square. This is the formula for the force acting between the two charges Q1 and Q2. Okay. Force being a vector quantity, I'll put a vector sign on top of that. Fine. So this K is called as Coulomb's constant. Okay. And this K will depend upon the medium in which the two charges are kept. So K will be equal to 9 times 10 raised to 9, okay, Newton meter square per Coulomb square if medium is air. Okay. If the medium is something else, then the K value will also be something else. Now, K is also given by a formula 1 upon 4 pi epsilon, where epsilon is called as permittivity of the medium. Permittivity of the medium. Now, the epsilon value on 0, epsilon is in general, epsilon 0 is permittivity of air or vacuum. If the medium is air or vacuum, then we denote it by epsilon 0, and epsilon 0 value is equal to 8.85 times 10 raised to minus 12. Okay. The unit will be Coulomb square per Newton meter, right? So this is the definition. This is the derivation, you can say, and the definition, I'll come to that. But here we have seen that the two charges are like charges. Now, if one of the charges is opposite charge, okay, suppose Q1 is positive and negative, all the remaining thing remains the same, then also same. Now, the force will be same, K times 1 2 over r square. But because one of the charges is having negative charge, you will get a negative here. Okay. But that negative is telling you only one thing, that this force will be attraction. Opposite charges, they are always resulting in the attraction force. And when the like charges are created, then the force against them is repulsion force. Okay. So when two like charges are there, the force of when two like charges are created by some distance, and the force between them will be the force of repulsion. The value will be K into Q1 Q2 divided by R. And when the two charges are of opposite sign, okay, one is positive, one is negative, then the force will be attraction. There will be a force of attraction. Is that clear? So this is the concept of the force between any two charges kept in a particular medium. Now let us write the definition. The definition says that, let us write some highlighting point also. The definition is force acting between two point charges is either attraction or repulsion, and its value is equal the product of the two charges and equal to the product of the two charges divided by the pair the distance between them. Okay. And appropriate K value or epsilon value is taken. Okay. So that was all about force between two point charges. Okay. That's all for today. The next video we will be solving some numericals related to the force between two charges. Bye.